All right, we're going to take a quick look at the summary lesson of vertex form, solving a problem, and coming up with its equation that's necessary, as well as looking at transformations. So here we've got a sample of what vertex form is in general, and we're given a problem that a baseball is hit, reaches a maximum height, key piece of information, 25 meters, 2 seconds after being struck. If its initial height was 0.5 meters, determine an equation in vertex form that represents the height of the ball versus time. So, in terms of the equation, if that's the generic one, what we're going to need then exactly that. So the AH and K values. So to do that, we have to use the information that's in the question. Now, knowing that the highest point has a height of 25 meters and took 2 seconds to get there. Well, here's where we gotta think of a couple things here. So if the highest point for this ball, and it's gonna get struck about here, and I'm gonna go up, hit a maximum height, and then come back down. So that is where we have to kind of anticipate the parabola. That's what the whole look of it is going to be. So it's going to be a maximum height of 25 meters at approximately 2 seconds, meaning this will be time and this will be height. So we can change the variables if we like, or we can just simply go ahead and just assign them. So we can say let y represent height of the ball and x represent time. After, well, actually, just leave it as time. So the information that we have then is given to us that the maximum height is 25, and it happened after 2 seconds. That gives us our vertex. So the vertex is the x-coordinate, or in this case the t-coordinate, which can be interpreted as the h. So there's lots of different variables, but it took 2 seconds to reach the maximum height of 25 meters. So again, 2 seconds to go from there to there, and then to reach that maximum height took 2 seconds. So there's the maximum height given to us. So that's what we're going to be using for h and k. So h will be a 2, k will be positive 25. So the only thing left to do is find the a value. So we're going to need to use some other piece of information. What else were we given? Initial height was 0.5 meters. So for initial height of 0.5 meters, now again, using this little diagram here, in an ordered pair, the initial height time is 0, and the height will be 0.5. So we can use that piece of information to then replace what we have here and come up with the a value, because our y is the height, 0.5, the x is the time, which is 0. So all we're going to do now is simply solve for a. So we are going to take this equation information, manipulate it. So this portion in the bracketed here, 0 take away 2 is negative 2, and then when we square that, we're going to get 4. So that whole expression is going to turn into 4a. Trying to solve for a here, so we're simply going to subtract 25 from both sides. And that'll leave us with a new equation that tells us that 4a, maybe we'll move this over the line up a bit, whoops, is equal to negative 24.5. And trying to keep it lined up a bit. And then dividing both sides by 4. So just trying to get so copy and paste and help us out here. So if we divide that by 4, that's going to give us a negative 6.1 for the particular a value, not the 4a. So our final equation then becomes same as this one here, but now we have the a value. So there's our final equation. And if you'd like, we can take a look at the graph of that. All right. Now, something is a little off because the a value is negative, so that parabola should have been opening down. Let's see if maybe, let me try that again. Still coming up with the same graph. Well, that's interesting. Okay, obviously the software is picking up the wrong values here. Let's try this again. And we're going to graph. Oh, that's better. Okay, so there's our graph. And clearly the ball's going up in the air and lands back down. And key features, the vertex is going to be 2 and 25, so we need to worry about that. Okay, so that's getting the equation in vertex form. Now, in order to compare that for graphing purposes, I'm simply going to plot parent graph. So there's the parent graph. Well, I lost my equation, but anyways, don't really need it. The parent graph then is the original one, and we're going to do a little comparison in terms of algebraic transformations now. So to go from this particular graph, your parent graph, to that one, there are obviously some transformations that have taken place. And we're going to take a look at what they are. Clearly, the parabola has reflected. Instead of opening upwards like the parent, it's opening downwards. And that's because of the negative sign. So let's indicate that. Okay, so we have that. So reflection in the x-axis. Clearly the parabola is thinner than the original one, and that is as a result of the a value here not only being negative, but being equal to 6.1 and negative. So we have a vertical stretch by a factor of 6.1. Okay. So the vertex was clearly moved as well. So it has gone from 0, 0, 0, 0, and it's moved to the right. What's causing that in the algebra? Well, this value right here. Okay, so that is your h value. So h equals 2, which causes a shift right 2 units. And the last thing is clearly the vertex has gone all the way up here to a height of 25. That value there. And again, we have our transformation. So we have the k value is 25, giving us a shift up 25 units. Okay, so this is just a very quick little summary of problem solving, coming up with equations. You need to find all the different values for A, H, and K, depending on what's given in the question. You got to use all the information. And then lastly, just to review some of the sketching part and the graphing part and transformations. Here we have the parent graph of y is equal to x squared, opening upward, vertex 0, 0. Clearly there's been some transformations. It's obviously stretched a little bit thinner and reflected. Shift, and the vertex has gone to the right and up, and that's reflected in this other graph.